Hello friends, today we will discuss about the linear convolution and circular convolution. First, the circular convolution and linear convolution is the method of the find the linear convolution of two signals. It is used in DSP and digital signal processing and or other signal processings. Okay, now first we will do the circular convolution. Okay, so in circular convolution, the circular in we will do in the Matlab. So in Matlab, the circular convolution has a built-in function which is cconv. We can do this circular convolution with cconv. Okay. First, we will set up our program and sequences. Okay. We will take the sequence, which is 1. You can take any sequences. Okay, first for the circular convolution, it is need to make the x and h length is equal. Okay, now x and h length must be equal. If you don't wanna see this x and h in output, just put the semicolons in. And now I will do the circular convolution. This is the circular convolution built-in function cconv, and this put the in this cconv put the first signal x, then h, then the how much sample you have taken. Here this is the 6 sample I have taken, so I have put 6, and then I will stem this signal in window. So this stem and I comma I will take the field to fill the this field statement take the full graph. Okay, now run it. Oh, I just skip one L. Now I have to run this. This is the circular convolution graph. You could see this, and this is the circular convolution result: 3, 25, 14, 21, 28, and 29. Okay, now first we will do the circular convolution in the method of linear convolution. Here I have made a program on circular convolution to linear convolution format. N1 equals first take the length of the x, n1 equals to length of x, and n2 equals to length of y, h, and n3 equals to n1 plus n2 minus 1. This is the length of the output samples. X pad equals to this is the zero padding format. The zero pad of the x is x comma 0 comma 1 comma n minus n1. This is n3 minus n1 because the length of the n3 is the length of the output. So as we know, the circular convolution need to same say number of the sequence, so we will put the number of zeros which is less than n3. So n3 minus n2, that's n3 minus n1. That's also applicable for the y2 y pad. Now do the circular convolution. We find that in x h n3 and v equals to the linear convolution. Okay, if we run this program, then you could see the circular convolution and linear convolution. And there is the graph of circular convolution and linear convolution. The circular convolution is C. You can see this C equals to 1 2 4 6 8 10 5 6 and V equals to 1 2 4 6 8 10 5 6, and the circular convolution graph and linear convolution graph is same. So the linear convolution and the circular convolution in the method of linear convolution, in Matlab, this is the code for the Matlab. Okay, this is the main vital point of this code. This is zero padding. Zero padding in this function will take the sequence of x, which is 1 2 3 4 5 6 in x, and zeros, which is n minus n3 minus n1. n3 equals to n3 minus n1 equals to 6 plus 3 minus 1 equals to 8. Okay, so 0 minus 1 comma n3 minus n1 equals to 2. Okay, so it will put 2 zeros, and here in h it will put 5 zeros, n3 minus n2. So, and after this this cconv will take the x, h and n3. In Matlab, the x and h will be replaced by the xpad. Okay, now we could see the run program. You have seen earlier, this is the circular convolution. So that in this process you could do the circular convolution in the linear convolution method and the circular convolution in Matlab easily. Please like, share and subscribe this way, and subscribe my channel please. Now goodbye to all.